Hello everyone. If you are struggling with isosceles triangles, then this video is for you. Math doesn't always make sense, but food always makes sense and money always makes sense. So I like to take a viewpoint of looking at this like a budget, and I'll kind of explain that a little bit more in a minute. But before we get into the budget view, we have to talk about the parts of an isosceles triangle. So first, let's just look at and name every single part. So what is the vertex angle in this isosceles triangle? We would call that angle C. Angle C is our vertex angle. The legs are AC and BC. Those two legs, those have congruence markings on them. We'll come back to that in a minute. The base is the side that is not a leg, which is side AB. And the base angles are angle A and angle B. Okay, so before I had kids, I tutored math every now and then. And so let's say that we know that for a triangle, the budget is 180 degrees. So let's say that I made $180 per month. That $180 went purely to me. That was just my fun money, my fun spending money. But now that I have had kids, I had twins, they're boy-girl twins named Jay and Ellie, I have to divide that money up a little bit more. It's still our fun money, but it's our fun money that I share with my children. And so when I talk about a budget, what I mean is that let's just pretend that my budget for a triangle is always going to be $180, which we're going to call 180 degrees. We know that the angles of a triangle add up to 180 no matter what. So no matter what angle C is, no matter what angle A is, no matter what angle B is, they have to have a total sum of 180. So before I had kids, that was just angle C. I call that the mama angle, the vertex angle. We're going to refer to this top one as the vertex angle. And I call that the mama angle. That was 100% to me. But now that I've had children, it has become a triangle where we split the fun money, okay? And so the legs are side AC and side BC, okay? And then that third side we're going to call the base, and the base angles sit on that base. So I call those angles the base angles. I also refer to them as Jay and Ellie in this video. Those are the twins. And so why do I call those the twins? Well, that is because of this isosceles triangle theorem, which essentially says that if you have two sides of a triangle that are congruent, two legs that are congruent, then boom, it's an isosceles triangle. And if it's an isosceles triangle, then the angles that sit on that base are going to be congruent. So not only are these legs congruent, but those base angles are congruent. So angle A is congruent to angle B. What does the converse of that theorem say? You can sit here and read it if you would like, but essentially what it says is the opposite. It goes forwards to backwards and then backwards to forwards. If you know that two angles of a triangle, of the three, are congruent, then boom, it's an isosceles triangle. And if it's an isosceles triangle, then you know that those legs are congruent. So if you have the leg markings, you can add the angle markings on the base. If you have the angle markings, you can add the leg markings. That's all the isosceles triangle theorem tells us. So how does that relate to a budget? Well, after I had children, I still have a 180-degree budget each month, but I get a certain amount of money, and then because I have twins, both of them get a certain amount of money, but to be fair, they have to get an even amount of money. So we still add up to 180 no matter what, but we're dividing the money a little bit differently. So that is just how I view these problems. No matter how they turn them, I still highlight. I'm a very visual learner, so I like to highlight these every time. So we have done our parts of an isosceles triangle. We've done our theorems. Let's do some practice, because that's where people tend to struggle the most. So I'm going to color code this. I'm going to color code the legs in blue. So the isosceles triangle theorem tells me that if these legs are congruent, boom, it's an isosceles triangle. If it's an isosceles triangle, here's the base, that's the third side, and the angles that sit on this base are going to be congruent to one another. So there's Jay, there's Ellie, and what this picture is telling me is that I have spent 28 degrees or $28 on myself that month. And we want to figure out what the value of X is. So keep in mind, how much do I make each month? Well, the sum of this triangle is going to be 180 degrees. And how much did Mom get to spend on herself that month? Oof, not very much. I'm going to subtract 28. I have $152 left to spend evenly between my kids. Well, because they're twins, it would not be fair if I divided those a different amount. So because this is an isosceles triangle, I'm going to divide that by 2 because those base angles should be congruent. So each of those base angles is going to be 76 degrees. 152 divided by 2 evenly, split evenly, is 76 degrees for each of those angles. So what is one of the base angles? 76 degrees. because those angles are marked as congruent. So Jay and Ellie each get 76, and then Mom that month only got 28. Okay, so what have they done in number 2? Number 2, they've kind of turned the triangle a little bit. So here's a leg, here's a leg. Okay, so both of those legs are congruent, so boom, isosceles triangle. Because it's an isosceles triangle, here is the base, and the angles that sit on those base are going to be congruent. So if this one's 54, immediately I get to fill in a 54 over here as well. I get to fill in a 54 in both of those spots. That is Jay and Ellie. They get the exact same amount of money there, okay? What are we trying to figure out in this picture then? I'm trying to figure out an angle. I'm trying to figure out this vertex angle. So Jay gets 54, Ellie gets 54. Those are the twins. So I'm going to take 180, and I'm going to subtract off what I spent on both of those twins. Minus 54, minus 54. And when I do that, that's going to give me a remaining amount that is left for my vertex angle, which I like to call the mama angle. So that angle is a 72-degree angle. So x equals 72 degrees. There are 72 degrees remaining for that vertex angle, which I refer to as the mama angle. Okay, so even though they've rotated the triangle, that base, that pink one, is still going to be the non-congruent side. Okay, so number 3, still talking about angles, so let's color code it. Here are my legs. The isosceles triangle theorem tells me that if I have 2 sides of a triangle congruent, then boom, isosceles triangle. If that is an isosceles triangle, then I have a base. Oh goodness, undo. Then I have a base, and so I'm going to color code that to be pink. And those 2 angles that sit on that base are going to be congruent to each other. So this pink angle is going to be congruent to this pink angle, and their measures are equal. So I do not know the mama angle. I do not know the vertex angle in this picture, but I do know that these 2 angles that are given should be congruent to each other, which means that they have equal measures. So even though I don't know how much was spent on the vertex angle, I do know that these 2 measures should be equal to each other. So I can take the expression 4x minus 20, and I can set it equal to 3x. Okay? Those are going to be equal because Jay and Ellie should have the same amount of money no matter what each month. And so I'm going to subtract 4x from both sides. This makes people uncomfortable for some reason because it makes your x negative. But that is okay. That is negative 1x equals negative 20. So I divide by negative 1 on both sides, and I get that the value of x is 20. Let's check ourselves before we wreck ourselves and plug that back in. If I were to check this, plug it back in, and I plugged in a 20 here and a 20 here, let's make sure that they actually are the same, that the kids get the same amount. 3 times 20 is 60 degrees. And then 4 times 20 is 80, minus 20 is 60 degrees. So both of these would be 60 degrees. And in fact, if you look at this overall, if I wanted to figure out how much the vertex angle is, I could do 180 minus 60 minus 60. And that gives me 60 degrees left for the vertex angle. So Mom that month would get 60 as well. So this is actually not only an isosceles triangle, but an equilateral, because all 3 amounts are the same, which also means that this third leg, the one I originally did in pink, would also be congruent to the other 2 legs. So this would be equilateral. But we will come back to that in a later video. All right, number 4 is a right triangle. Why do I want to notice that? Because people tend to miss that we know that that's a right angle, but we know that that has a mathematical value to it. That has a number I can put there. So there are 2 congruent sides. So boom, it's an isosceles triangle. And then here are the 2 base angles that sit on that base. And then the vertex angle is a 90-degree angle. So I'm going to fill in 90 there. I'm going to fill in 90 degrees. Okay? So multiple ways you can do this problem, but my favorite way is to think back and say, okay, well, if this is 5x, what do I know that the other expression is? That other expression is also going to be 5x. And so I could add up all 3 of these pieces. The triangle angle sum theorem just says, hey, if you add all 3 of these, it's still going to have a budget of 180. Whatever Jay gets, plus whatever Ellie gets, plus whatever I get that month, should still be a budget of 180 degrees. So you could combine like terms. And then we would solve for x. So we'd get 10x equals 90. So x equals 9. Again, check yourself before you wreck yourself. Go back and plug it in. And you get 45 degrees for each of these angles. So this is a special right triangle where each of these angles are 45. So Jay and Ellie would both get 45. But all they wanted me to solve for was x, so x is 9. Another way a student did this one time is they went ahead and just subtracted this 90 from the other side, and they said, okay, well, the mama angle is 90, so I have 90 degrees to spend. So a shortcut would be to do 5x plus 5x equals 90. Still get the same thing, 10x equals 90, and x equals 9. So just kind of doing some of that math in your head to save yourself some time. Okay? All right, so now the entire first row is talking about angle measures. This next row, part of them at least, are talking about sides. So I want you to notice I have no legs marked as congruent as I did in questions 1, 2, and 3. But in number 5, 1, 2, 3, and 4, in number 5, I do have base angles that are marked as congruent. So I have an angle here marked congruent to this angle here. So boom, still an isosceles triangle, but this is the converse of the isosceles triangle theorem, which says that if 2 of the 3 angles are congruent, then it's isosceles, and the legs across from those angles are congruent. So here are the legs. I get to add congruence marks on those legs. So what is the value of x? The value of x is just 6. If this leg is 6 from here to here, then this leg must also be 6 because of those markings. If I did not have those pink markings, I would not have been able to solve this problem. But it's an isosceles triangle, so the legs must be congruent. So nothing to do with budget there as far as 180 degrees goes, because these are talking about legs or side lengths. But we do know that those side lengths must be congruent. And I hope that as the mom, my legs are congruent. If not, I'd be wobbling all around, okay? All right, again, something very similar here. I have an angle, an arc, that's what that's called, an arc, a piece of a circle, on point P and on point R, so those angles are congruent. 2 out of the 3 are congruent, so that makes this the base. Boom, it's an isosceles triangle, and these legs are congruent. And what they've done on this problem is they've added extra information. They have given you 6x minus 12 here, 3x plus 12 here, and 9x plus 2 here in order to make sure that you understand which ones you can set equal. So if these are the base angles, the sides across from them are the ones that are going to be congruent. Those are the legs. So as far as deciding who can I set equal, I'm going to set 6x minus 12 equal to 3x plus 12. The 9x plus 2 is just really on there as number 1 distractor information and to eventually show you that that base is a different length than the other 2. Okay, so I can set these equal, and I'm going to solve for x. So we're going to do some quick algebra here. So 3x minus 12 equals 12. Add 12 to both sides. 3x equals 24. 24 divided by 3 is 8. Always check yourself before you wreck yourself. 6 times 8. 6 times 8 would be 48. Minus 12 is 36. So that side length, again, nothing to do with angles here, but that side length is 36. Let's make sure the other side is 36. 3 times 8 is 24. 24 plus 12 is also 36. So both of those legs have the same length as I expected them to. If you wanted to check and see if this was an equilateral triangle as well, you could plug it in here. 9 times 8 is 72, plus 2 would be 74. So this is not equilateral. 74 is different than those two 36 lengths, and so this would have to just be isosceles. And then number 7, I've given y'all a challenge question. First of all, I've turned it sideways. So here's a leg marked congruent to this leg. And I've given you the mama angle. The mama angle on the left triangle is 51 degrees. 51 degrees. So here's my base. That is, boom, it's an isosceles triangle. And these 2 base angles must be congruent. The x and then part of this 90. Notice they have a 90-degree angle here, and they don't do that for funsies. Okay? So how do I figure out how much Jay and Ellie get, my twins, that month? If I went and I got a $51 pedicure, I would have $129 left to spend on my twins that month. So 180 minus $51 is going to be $129. But that is what I have to split evenly between my twins. So I have to take that 129 and I have to divide it by 2. So how much is left for Jay and Ellie that month? 64.5. Okay? 64.5. But this triangle, this family unit, is connected to another family unit, okay? So when I'm looking at this, I have another set of twins going on, and how do I know that? Well, because these legs are marked as congruent. So let me change colors. These legs are marked as congruent. So that means that this must be a different isosceles triangle, where this is another set of twins, but they are smaller than my set of twins. They're getting less money. But I do know that pink plus green adds up to 180. So let's write that out. 64.5 plus this little amount, y, because that's going to be the same on both of these, should add up to 90. So 90 minus 64.5 gives me 25.5 for each of those little sets. 25.5. So this is this one right here, y equals 25.5. And then its twin, y, is going to be equal to 25.5. So how do I figure out what the mama angle of that triangle gets? That mama angle is going to be whatever is left over after you spent 25.5 for each of her twins. So you're going to do 180 minus 25.5 minus 25.5. And you get 129. So this mom angle has a lot more to spend on herself. That mom angle Z is going to be 129 degrees. So I hope that this helps. I just like viewing this in terms of money because I just feel like it helps a little bit more, especially as we rotate and turn these triangles. Color coding helps a ton.